My name is Keshwani. That's K-E-S-H-W-A-N-I, Keshwani. We are here because we want to prepare for the GMAT. We have been solving GMAT math problems out of this book here, GMAT Review, the official guide, the 13th edition. If you do not own this book already, purchase one immediately. You're going to need it. The problem that we are about to solve is the one that you will find on page number 283. Please turn to it, page 283, number 97. In problem 97, we are told that we have two integers x and y, and the question simply is x greater than y? Let's see what they tell us in the first statement. In the first statement, they tell us that their sum is positive. Their sum is positive. Does that tell us if x is greater than y? The answer, of course, is no. This is no good. For example, we can have 2 plus 2. 2 plus 2, of course, is greater than y. And here, x equals y. Or we can have 3 plus 2 is greater than 0. And here, x is greater than y. Or we can have the other way around. 2 plus 3 is greater than 0. And here, x is less than y. To say nothing of the fact at all that the negative numbers are also possible. Of course they are possible. For example, we can have 7 plus a negative 6, which is also more than 0. Since x is positive 7 and y is negative 6 here x is more than y. So we do not know. X could be equal to y, x could be more than y, x could be less than y. First statement does not do anything. The first statement is not sufficient. First statement is not sufficient. A, D, B, C, E. Because the first statement by itself does not do the job, answer cannot be A, nor can it be D. It will have to be either B, C, or E. Let's look at second statement. In the second statement, they tell us that y raised to x is less than 0. Now we are getting someplace. If a number raised to some power is less than 0, if that quantity is negative, that does tell us something about the number that is being raised to a power. For example, even if x is negative, for example 3 raised to negative 2, we'll have to have, since it's less than 0, we have to have odd power. 3 raised to negative 3 equals same as 3 raised to 3, which is 1 over 27, which is a positive quantity. But we need it to be negative. You see, it became positive. That's what I'm sorry. I realize now what I'm trying to point out here. You see, just because the power is negative does not mean just because some number is raised to a negative power does not make the quantity itself negative. The quantity is still positive. So how can we have y raised to x less than 0? The only way we can have that is if the number that is being raised is also negative. This is negative. And then we end up with 1 over negative 27, which is less than 0. So the fact that y raised to x is less than 0, this implies that y must be negative. Y would have to be a negative. A negative power, a negative number raised to some power would be less than 0. For example, negative number raised to a 3 is simply negative 1/8, which is less than 0. So y must be negative. But it does not tell us if x is more than y. It does not tell us that. X could be more than y, x could be less than y, x could be equal to y here. But we do know for a fact that y, whatever it is, has to be negative number. For example, let's look at a situation where x is equal to y. And the whole thing will be 0. For example, negative 2 raised to negative 2 will not give us something less than 0. We need an odd power. In order for this quantity to remain negative, the power has to be odd number. So let's put negative 3 raised to negative 3. So here it will be negative 1 over 27, which is less than 0. But as you can see here x equals y. Or we can have situations where x is more than y. Why not? X can be more than y. For example, you can have negative negative 1 raised to negative 3. Negative 1 raised to negative 3 is just negative 1 over 8, which is still less than 0. But here, x is more than y. X is negative 1 and y is negative 3. Or we can have situations where x is less than x is less than y. For example, we can have negative 3 raised to negative 1. Negative 3 raised to 1, negative 1 is simply negative 1 over 9. Oh, sorry, 1 over 3. And here, x is less than y. So, is x less than y? Or is x more than y? Or is x equal to y? We do not know. But one thing we do know from here, it does tell us something. It's not completely worthless. It does tell us something. It does tell us that y, whatever it is, the y which is the base here, has to be some negative number. Negative 3, negative 1, negative 3. It has to be a negative number. This implies that y must be negative. But it does not enable us to ascertain if x is more than y. Second statement by itself is also worthless. Answer cannot be B. Let's put them together, shall we? Let's put them together. Together, 1 and 2. The first statement tells us that their sum is positive. Second, this comes from the first statement. Second statement tells us that y is negative. We just found out that from second statement we know that y is negative. Well, if their sum is positive and y is negative, that implies that x must be positive. X must be positive. Because if you're adding two numbers, and their sum turns out to be positive quantity, and you also know that one of those two numbers is a negative quantity, then the other one has to be positive, obviously. So putting them together, it does tell us that x is positive. X is positive, and we know that y is negative. X is positive, and we know that y is negative, therefore y is more than x. Is x more than y? The answer is yes. We do not know exact value of x and y, but we don't need to know that. All we have to understand here is that putting the two statements together, we arrive at a conclusion that x, whatever it is some positive quantity, and y, whatever it is a negative quantity. Y was raised to an x, wasn't it? Yes. And the second statement, they tell us that y is raised to negative x. That's how we got that y must be negative. So that's it. Putting the two statements together answers the question that x must be greater than y because x is positive, y is negative. You want to do one more? Yes? Let's do one more. Number 98. Before I start number 98, if you excuse me just for 2 seconds, I'm going to go in the back of the camera and see how much time I've taken. Just give me one brief second. I'm still here. Well, let's do one more, shall we? Number 98. In number 98, they're asking us, is r times s times t equal to 1? Let's see what they tell us. In the first statement, they tell us that r times s equals 1. In the first statement, they tell us that r times s equals 1. This is worthless. It's worthless because tells us nothing at all about t. There are 3 variables here. We know the product of these two is 1, but what about t? If t is 1 also, then of course r times s times t would be 1. But if t turns out to be something other than 1, then their product will not be 1. Then r times s times t will not be 1. We have to know about t. Is t 1? This does not answer that. So first statement by itself is worthless. A, D, B, C, E. Since the first statement by itself does not do the job, answer cannot be A, nor can it be D. Let me switch the marker one more time. Statement number 2. In the second statement, they tell us that s times t equals 1. Again, this tells us absolutely nothing at all about the missing variable r. It tells us absolutely nothing at all about r. We are told that s times t is 1. If r also happens to be 1, then s times t is 1, and if r also happens to be 1, then r times s times t would be 1. But if r happens to be something other than 1, then their product will not be 1. This by itself does not do anything, because it doesn't tell us anything about the r. Answer cannot be b either. Let's put them together, shall we? Let's put them together, 1 and 2 together. Putting them together, statement 1 and 2, we find that the first statement tells us that r times s equals 1, and the second one tells us that s times t equals 1, or the other way around, doesn't really matter, and therefore they are equal. R times s must equal s times t. What do we conclude from that? What do we infer from that? What do you surmise from that? What do you gather from that? We gather that because the s appears in both sides, if we were to divide both sides by s drops out, and this tells us that r equals t. R equals t. But the question is, what is r times s times t? Now we know that r equals t, which means we can replace r with t, or t with r, and we'll have t times s times t, or r times s times r. So we'll end up with s times t squared, or s times r squared. Can we tell if this quantity equals 1? The answer is no. We know nothing about the t and the s and the t. This one is, we are in the same situation. In the first statement they tell us that s times t is 1, so this is 1. We don't know what t is. In the second statement they tell us that if you were to look at this way, so this is s times t, we do not know what t is. We know s times t is 1, but we don't know what t by itself is. Similarly here, we do not know what r by itself is. We know s times r is 1, but we do not know what r is by itself. It was completely worthless. All that work for nothing. The answer is E. It cannot be calculated. It cannot be said with certainty if r times s times t is 1. Alas. I'll see you tomorrow, okay? Bye now.